Okay, so what we have here is another example of a system of equations, and what we're going to do is solve it using the Gauss Jordan elimination method. So the first thing I'm going to do is to write the augmented matrix that corresponds to this system. So I'm going to have 4, -3, and I'm going to put a line where the equal sign would be, and that's going to be a 7. And then we have 5, 2, 3. Okay, so remember, the goal normally is to have 1, 0, 0, 1, and then whatever's on the right-hand side is your solution. But sometimes it's going to be very difficult to get the 1 where we want it to be. So we're just going to deal with whatever it is in the upper left-hand corner. And with a little caveat that if you can interchange the rows to get the 1 in the upper left-hand corner, do so. But here we don't have that option. And there are some crazy things that you can do to get that 1, but really the 1 is not that important. So what I'm going to do, again, pretending like it's an elimination problem, I know that I want to get a 0 here. That's my first step. So basically with Gauss Jordan, what we're looking at is we get the 1 where we want it, and then the rest are zeros. So we move from left to right. Okay. So what I'm going to do, and again, calling these R1 and R2, thinking about elimination, I want to get rid of the x in the 5x equation. So I'm going to take -5R1, and I'm going to add 4 times R2, and that is going to be my new R2. And again, that's because R1, for all intents and purposes, is the way we want it. So -5R1 is -20, +15, and -35. And 4R2 is 28, 12. So let's see what we get here. So adding those together, we get 0, which is what we want. This is 23, and I'm a little scared right now because 23 is not a nice number. But the right-hand side is -23, and that's a good thing. So that means my new matrix is 4, -3, 7, 0, 23, -23. Okay, so looking at that, remember that there's a system that corresponds to this. 4x minus 3y equals 7, and 23y equals -23. Now, if this was a system, what would you do? You would obviously divide the second equation, both sides, by 23. That's why we're allowed to divide any row of a matrix that we want to in the augmented form. So I am going to divide this row by 23 because that row is really an equation. So I'm not going to go through a whole big deal about that. I'm just going to do it. So first row stays the same, and now we have 0, 1, -1. And yes, what we know right now is that y is -1. So this is really exciting. We already know what y is. So what I'm going to do, though, is I'm going to complete the Gauss elimination here, and I'm going to say, well, at this point, I want this to be a 0. So thinking about the elimination, how do I make that a 0? Well, again, calling this R1 and R2, I'm going to say that I'm going to take 3 times R2, and I'm going to add it to R1, because that's going to get rid of the 3's, and that is going to be my new R1. So that's going to be, so 3R2 is going to be 0, 3, -3, and again, I'll put the line. We have 4, -3, 7. When I add those, I get 4, 0, 4. Now, is that better than what we had before? Absolutely. My new R1 is 404. My R2 from before was 0, 1, -1. And just one more step, we know that we're allowed to divide any row we want to by any number we want to. So I'm going to divide the first row by 4 because we can now. And what that corresponds to is x equals 1 and y equals -1. Keep in mind that we didn't have to do that. If your goal is to solve the system of equations, we always do go back. Remember that this means that 4x equals 4 and 1y equals -1. So it always corresponds back to an equation. So you didn't necessarily have to do that. I'm just illustrating that, yes, this is why you divide a row by a number and it's still valid. So hopefully that example was not too bad, and we're going to be doing some more, so stay tuned and thanks for watching.